Okay, so I want to, I'm going to create a subclass. Oh, let's call it person. And they're just going to have, we're just going to give them a name. Okay? Now, actually, every one thing that they leave out, but now let me see if I can. Need to. Let's make this a bit bigger. Okay, now, whenever you say public class, the way you identify that you're extending or you're subclassing is you say extends. And Java has single inheritance, meaning I can only extend one class, and that's it. And notice that I wrote public class person extends object, and there's no red squiggly. So that means that the compiler's happy, right? So this object, and actually we can take a look at it, we can actually see the source. So here, in the java.lang package, which is imported by default always, public class object. And it's got a bunch of stuff in here that the details of which are not as important as the fact that it just exists. So we can either say extends object or not. If we don't say it, then Java will put it in for us. So we don't need that. All right, so our person, we're just going to say, is going to have a single name. And when we instantiate a person, we're going to have to give him a name. And just for these purposes, we're not going to be allowed to change our name. In a more complicated one, we might allow that, but. Okay, so here I've defined a constructor. What is it complaining about? Public string, no, name. Yeah, it needs a. See, when in the UML diagrams, you just say what the type it is. So the type of the argument, in this case, the signature is string. What you call this is completely arbitrary and not part of, that's actually not part of the class. What that name is, in any of the methods or any of the constructors, what the name of that object or variable is not really part of the class. That's just an arbitrary type of thing. But in this case, what we want to do, and this is kind of a pattern, is that we set our name to be name, and now it's suggesting that we can make it final. And remember we talked about final? And in this case, it's kind of a good idea. That is, once what that does is that says that if we try to do this, okay, so here I assigned it to the argument, and now I'm trying to reassign it, but if we see what it's complaining about, it says variable name, it says might have already been assigned. So the compiler is smart, but it's not like a genius or anything. So it says it might have been already assigned, and if it just kind of looks up one line, it sees that it has been assigned. So final, we can't do that, and that's actually a good thing. It's kind of a belt and suspenders to prevent us from accidentally renaming something or reassigning something that we don't want to happen. And if we want to allow it to be reassigned, then we would not define it to be final. So I'm going to leave it at final for now, just because, as I said, one of our rules for this is we're going to say it can't be changed. Okay, so Okay, I'm going to define a main class now. I'll put it in the same thing here. And let's, so here's how, oops. Okay. Oops. And again, at some point I'll stop doing this, but I really want to emphasize that some things that you see a lot of are actually more going on than you realize. So declaring a variable is different than assigning a variable. So here we declare the variable Tom to be a person, and here we assign Tom to be a new person. So declare, assign, two different things. So now at this point, let's see who we got now. Again, now actually you see all these overloaded methods of print, printf, and println. Okay, so let's just do this. Now, do you remember what happens when we print an object reference? Well, okay. So what do we get here? What we get. Oops. So, there we go. Okay, what we get when we printed this out was actually the fully qualified name of the class, a little @ and then some gobbledygook, which is actually something that's called the hash code or related to the hash code. It's just, again, for those of you who are used to C or languages like that, you may think of that as a memory location, but that's wrong. It's not a memory location because Java does not have access to the memory of the computer. It lives inside something called a sandbox. And so that's just an arbitrary number that's been assigned. So where does that come from? Well, in the object granddaddy class, there's a method called toString. And the fact that it exists is verified by the fact that I can type in tom.toString and it will, the compiler's happy. There's no toString method here, so there's only one possibility, and that is whenever the compiler has allowed a method to be invoked by not complaining, it means that method must exist somewhere in the class hierarchy. Now, in this case, we're only one deep. We're just one level below the granddaddy class object. So the only possibility is that the toString method is in the class object. And when I run this, I get exactly the same thing as I did before. So that's at least evidence that what println is doing is it's actually taking the object and calling toString. Every object has the toString method by virtue of it inheriting from the object class. The object class defines public string toString. It provides this implementation of it, and that guarantees that every object has this method, guaranteed. So what did the virtual machine do when it got here? It said, okay, Tom, you're a person. Let's find toString in person. It's not there. So then it will go to the superclass, which in this case is object, and there it will find it, and it will invoke it. Is that clear? Is this? Now, the default toString, it kind of makes sense in the sense that it gives you all the information that it kind of has. It knows what it is, and this is related to its identity. I mean, it's just some gobbledygook that's unique. If I have other objects, they're going to have different bits of nonsense there. But if I have other people here, and I want to print them out, and these variable names and these strings are totally independent of each other. I could have called them completely different things. All right, so now I've run them, and it's printed one, and it's printed the other. And then notice that these numbers are slightly different, but the classes are the same. Looking at this, which one is which? You don't know, right? I mean, I could look here and say, okay, yeah, because I printed Tom first, then but that's not very useful, right? What would be more useful? To actually print the name, so I know who it is. How can we do that? We can do that by overriding the toString method, which is already existing in the object class. And we can override the toString method. And here's how we do it. Okay, now it's complaining. It says missing return statement. Why? I need to have a string. And you've all kind of done this to a certain extent, but this is what's happening when you do this. And then notice it has a suggestion here to add the override method. That's always a good annotation. This is called an annotation. We'll maybe touch on that a bit later. But this is just this is very helpful in that if I'm looking at this, I can see that this method is being overridden. And that means that there's something in the superlin class, and that can alert me to the fact that there may be something else going on. Okay, so now the toString will now return the name of the person. And so now if I run it, I can now see who's who. Now it's, that one is the one I called Tom, and that's the one I called Dick. Now, what if for some reason I also wanted that gobbledygook? For whatever reason, supposing I wanted to have that string that was in the object class. Usually I don't, but suppose if I did, then I could call super toString and I'll just sort of concatenate it with the name. And remember we said that I can call the immediate superclass method by saying super dot the method. And now, when I run it, I have the things, and notice these are different because every time you run the virtual machine, it has some. How does it assign these things? Who knows? These are totally arbitrary. But now I can see who's who, and I can now see actually what these values are relative to that, and I can also see exactly what type of thing they are. Because now here I haven't defined a setter. A setter wouldn't make any sense because I've set it once and I'm not going to be able to set it again. But it would make sense to define a getter. So I'm going to define a getter, and remember how I do that is I say refactor, encapsulate fields, and now it doesn't even let me select the setter. Why? Because it's final, and for some reason its default is not the ideal one. What I would want to do is put it after that. Okay, so and it generates the getter. That's the recommended way of of doing this, because if I do it, I will often figure it. So why worry about that? Well, let's got I already delete this guy, because what I want now, let's say we have certain, I want to have something that's already a person, but it's an employee, say. And I want that to extend person. All right, now it's complaining because of constructor stuff. And we'll get into this a little bit. Now in this case, because the superclass constructor had a signature that was string, I have to make sure that I call it like this. We'll talk more about what that's about. Now, without doing anything more, okay, so I've done two things here. Okay, first, I've defined Harry to be an objective type person, but I've instantiated it to be an employee. So that should tell you something about how a subclass can always be assigned to a variable of type of the superclass type. Now the thing is, well, and I'll talk about this another time, but well, there's actually you may be thinking, why do this? Well, just hold on to that thought until another class. Okay, so now though, I want to see if I want to do a print line of Harry, and just to make it explicit, let's do his toString. Compiler's happy. Why? Because toString, every object has a toString. And the question is, what will we get when we on this line? Will we just get the object one, or we're going to get the person one? Again, remember what does the virtual machine do? It says, okay, even though I've declared the variable to be of type person, the object is actually an employee, which is a subclass. And so when I do a toString, I'm going to say, oh, employee, where's your toString? And he says, I left it in my other pants. So we say, okay, superclass, where's your toString? And there it is, so we'll invoke it. Now the question, so it'll work. Now the question is, what will this say? Any idea of what that'll say? Will that say person? Or will it say employee?
Yes, because inherited from the previous from the superclass, right?
That makes sense. But because it's an employee, it's going to say employee. Now, what you said makes perfect sense, and because the toString that was being invoked was actually the one in person. You're absolutely right about that. I mean, that's a good and logical way to think of it, but sometimes things aren't always good and logical. See, what's happening is that when the object toString actually is printing what the class actually is, what that object actually is. And what's strange about it is we declared this to be the type person, but we've instantiated to be an employee, and so it says you're really an employee, even though you said you're just a person, you're actually an employee. So that's what we're going to print.